Okay, it is February 1st, 2017, and in this video I am going to fix a problem with this board, or a perceived problem with this board. This is the PIF board, the PIF board for StarWriter, and what this board does is it is the board that controls the Laserdisc player. So I'm trying to finish up support for StarWriter with Dexter. So here's one of my Dexter units running over here, and this board used to work, but all of a sudden it stopped working for unknown reasons. So what happens when I power the board on is basically nothing gets sent to the Dexter. That makes it really hard to troubleshoot what's going on, because this board, the only way it can communicate with the outside world is either sending commands to the main CPU through this cable or sending commands to the Laserdisc player. It has no LEDs or any other way of communicating. So what I've done so far is I've hooked up a logic probe and checked the clocks. So there's a few things that could be going on here. One is the ROM could have somehow gotten corrupted. I don't really think that's it. The RAM could have gotten corrupted. I don't really think that's it either. This guy, the 6821, could have gotten damaged and stopped working. That's kind of what I'm thinking might have happened. Another possibility is the CPU itself might have gotten damaged. And the last possibility is maybe everything's working and it's Dexter that's the problem. So I think the first thing I'm going to do is probably check the communication on this cable to make sure that Dexter is really not getting anything and it's not a problem with Dexter. Once I've found whether there's anything going on, any communication going on the cable, then the next thing I'm probably going to check is this guy, because I'm kind of feeling suspicious about that. Something else I should explain is I actually spent a long time disassembling the ROM for this board, and so I want to explain what happens when the ROM gets powered on. When the ROM gets powered on, it immediately calls this function that I've called reset, and the first thing it does is it starts running a RAM test. Actually, the RAM test starts right about here. Almost the exact... it does almost nothing before it runs this RAM test. So the first thing it does is it runs a RAM test. After the RAM test runs, it runs a ROM test right here. And after the ROM test runs, then it will send a stop command to the Laserdisc player, also known as the reject command. Then it will send a play and a pause command to the Laserdisc player. And then it's going to test the IRQ, which stands for the interrupt request. So as long as we get a reject command and then a play and pause command coming over the Dexter, or the cable to Dexter, then we know that this board is probably working. Right now I'm not getting anything. Now you may ask, well, what happens if the RAM test fails or the ROM test fails? So what happens if the RAM test fails, it's right here, RAM test failed. It's going to load a code into the A accumulator. The code is 81 in hex, and that's just a constant that the programmers, actually the guy who programmed this is named Rich Witt. I know that because he put his name in the ROM as kind of an Easter egg. So Mr. Rich Witt, he just chose this value 81 arbitrarily and said, okay, 81 means the RAM test fails. So it's going to load 81 into the accumulator, then it's going to jump to this subroutine or method or function, whatever. I called it on fatal error. And what it's basically going to do is it's going to send a forward step command to the Laserdisc player. So it's going to pause and step forward one frame. And then it's going to, depending on what the error code is, it's going to do different, it's going to toggle the left and right audio. And you may say to yourself, well, why is it going to toggle the left and right audio? That's kind of dumb. But on the original Laserdisc player, there were actually lights, LEDs on the front of the player that would show whether the left and right audio was enabled or not. And so this is kind of a primitive way for the PIF board to send diagnostic information to the engineer, is by blinking those lights on the front of the Laserdisc player. So depending on whether the RAM test failed, it's going to send a certain pattern of lights. If the ROM test failed, it's going to send a certain pattern of lights. So, right now, there's no activity at all. So that tells me that either the CPU is, either the ROM program is completely destroyed, and so the CPU is just, running this bogus program and not doing anything, or it tells me that there's something wrong with this that's preventing it from communicating with the Laserdisc player, and the CPU is trying to send communication, but it's a problem with this, or there's a problem with Dexter not receiving anything. So that's why the first thing I'm going to do is check the ribbon cable to see if there's information coming across the cable. If I don't see any information, then probably the next thing I'm going to check is the ROM. I'm going to pull it off, read the image, see if the ROM program is still what it's supposed to be. If the ROM's good, then I'm going to check this guy, because I think this, if the ROM's good and if the cable's good, then this guy's probably where the problem is. Okay, I put the StarWriter ROM, PIF ROM, on my ROM reader. Read the information in, and the MD5 from the reference ROM on the internet matches this ROM exactly. So therefore the ROM is good. So now the next step is to check that 6821, and let me just show you what the schematic looks like. So here's the schematic for the PIF ROM, or the PIF board. But over here we've got the CPU, which is right here. Then we've got the ROM, which is this guy. Then we've got some RAM. I can't remember how much RAM, but it's not very much. Maybe 2K. RAM chip is right here. And then we've got this, where am I? This PIA 6821, which basically allows the CPU to connect to two different peripherals, or two different 8-bit buses. These 6821s have an A and a B peripheral, so the VGG board is the A peripheral, and all these signals start with PA, so PA0 to PA7. Then down here is the B peripheral, that's the Laserdisc player. It goes from PB0 to PB7, and here's all the little Laserdisc lines like jump trigger, scan C, remote control, standby, and odd and even field. And then all of that goes through this 244, which is a buffer, which is always on. And then it comes out here to the actual Laserdisc interface. And these are the lines that I'm capturing on my logic analyzer. So the way that the CPU talks to the Laserdisc player is it has to go through this 6821. It's going to put information on these data lines, and then it's going to assert or drive these RS lines and CS lines to tell this 6821 which peripheral, A or B, to talk to. And it can read from A, it can write to A, it can write to B, read from B. So I'm going to power off the game, or the board, put my logic probe right on here, power it on, and see if it ever changes. If it does change, then I know that this guy's bad. If it doesn't change, then this guy might be bad, but I'll have to set up some triggers and logic analyzer stuff and see. So I will be back. Okay, I think I found a problem here. Here is pin 20, low 14 is floating, nothing. And that's the remote control line. So, I think that means this guy's bad. The only other thing it might be is this 244 might be interfering somehow. But if the 244 is interfering, then I think it would either be low or high. I don't know if it'd be floating. So I think I should probably replace this guy. And I put in a different 6821. It's not a new one. It's a different one. So don't know if this one's good or not. But I'm going to power it on and let's see what happens. 15, 14, again, has nothing. 16 is ground, 15 is ground, and 14 is there, about 1.5, 1.2 volts. And this is a different 6821. I swapped it out. And so I am left to conclude the thing that I didn't think thought was less likely, that this 244 is causing problems. So I guess the next thing to do is remove this and see if the voltage climbs back to normal levels after I remove this. Okay, I've removed the 244. Got my scope ready, so let's see what happens here. 16, 15, and 14 is 0. That kind of makes me think that this isn't being programmed properly. So I guess I'm gonna have to go back to my earlier attempt of solving this and hook my logic analyzer after this and see if the commands are coming in to program it properly, because kind of looks like they're not, and if they're not, then I really don't know what could possibly be causing that. Okay, so since I couldn't figure out what was wrong with the 6821, I felt like I had no choice but to hook up my logic analyzer to it. So I have all these wires hooked up to it to monitor what's going on. I also rewrote the ROM and inserted a very simple program that would continually run in a loop and exercise the thing to try to understand maybe something was being sent in wrong on here, and that's why it wasn't coming out right. So basically I just wanted more visibility. And here's the little program that I wrote. When the CPU is reset, or when it powers on, it just disables interrupts, sets the stack to a certain memory address, and then it basically does nothing after that except call the 6821. And the first thing it's going to do is send a hex value of 3C to memory address 8003, which ends up going to the 6821, and then it sends a hex value D to 8002, which is also the 6821. Then it sends a 38 to 8003, then a 1F to 8002, then a 3C to 8003, and then it returns. So why did I explain that to you? It's because I can actually see this happening on the logic analyzer capture, and I think I see what the problem is. So here's the capture I made with the logic analyzer, and as you can see right here, I don't know if you can see that, but there's the 3C that corresponds with this 3C right here. So there's the 3C that gets stored to 8003, and I confirmed that looks correct to me. Here's the D that gets stored to 8002 that we can see right here. So that's so far so good. I'm going to skip to, here's the 38, which gets stored to 8003 right here. So that's looking right, here's the 1F to get stored to 8002 right here. And then the next thing that's supposed to happen is 3C is supposed to get stored at 8003. However, that's not what happens. Right here, instead of 3C being stored at 8003, 0 gets stored at 8003. So that's wrong. That's most likely what the problem is. And the question is, what could be causing that? Well, this value comes from all the data lines, D0 through D7. So let's look at the schematic and see what can influence those data lines. Okay, so one thing that can influence the data lines is the CPU itself. That's actually where the data lines are read and written. The CPU can write data lines to memory or peripherals, or it can read from memory or from read-only. It can read from RAM or ROM on the data lines. So the CPU is hooked to the data lines. The RAM is hooked to the data lines. The ROM is hooked to the data lines. And last but not least, the 6821 is hooked to the data lines. And let's see, I don't think there's anything else that's hooked to all 7 of them, or all 8 of them. I think there might be a few things that are, there's a few things that are hooked to just 1 bit of the data lines, but so those 4 things, CPU, the RAM, the ROM, and the 6821 are all hooked to the data lines. So one of those things, I'm guessing, is creating this problem of a 0 value being stored there where it should not be stored. So, can we deduce where the problem is without actually just replacing all 4 of those things? I mean, I've already replaced the 6821, so it's probably unlikely that it's going to be that. So, could it be the ROM? Oh wait, this is the ROM. Could it be the ROM? So, let's look back at our... If it's the ROM, then then the program probably would not run at all, because if the ROM wasn't working, the program would not run at all. And it's pretty clear to me from looking at the logic analyzer that the program's running. And even if I go a little bit back in time to right here, I don't know if you can see this, but here's 863C. And 863C, I'm pretty sure, is the instruction for the 6809 to load in this 3C. In fact, if we look right there, there's the 863C. So this kind of proves that the CPU is able to successfully load these instructions from the ROM. It is able to load the 86, it's able to load the 3C, and then for some reason after that it stores a 0 instead of a 3C. So I'm going to eliminate the ROM from consideration. Or sorry, I'm going to say the ROM is not causing this problem. Could it be the RAM? Well, if we look at these instructions, the RAM's actually not being accessed at all. The RAM has an address range from 0 to 2000, and there's nothing here that's getting close to 0 to 2000. Everything is loading or storing from 8000, and address 8000 is only touching the 6821. So I'm going to say the RAM is probably also not causing the problem. So that leaves either the CPU causing the problem or the 6821. I've already replaced the 6821, so I think it's unlikely that the replacement would have the exact same issue. So that means that I'm going to assume that the CPU most likely is what's causing the problem. And because if you look at this, the CPU loads in a 3C value into its accumulator, and then the next thing it does after that is it stores it to 8003. Like as soon as it loads it, you can see the instruction to store to 8003. It's right here. F7 means to store the accumulator, and here's 80 and 83. Okay, so that's another 8083. I didn't even notice that until just now, but that shouldn't be 83, that should be 80 and 03. But actually, you know what though, even though it says 83, I think it'll still work because when storing to the 6821, it only looks at like the lowest 2 bits. So the fact that this is an 8 doesn't even matter. But that's something to consider. Why does it say 8083 instead of 8003? Anyway, at that point, it should be storing a 3C right here, but it's storing a 0. So I think the CPU is probably causing this problem. It's easy enough to replace. So if I replace the CPU and the problem doesn't go away, then there's very few things left that could still be causing the problem. So I'm going to replace the CPU next and report back and see if that fixes it. Okay, I replaced the CPU with a brand new one, like a socket and a new CPU, and the problem did not go away. So now I'm like really stumped. Okay, I'm finally making some progress here. So I took the PIA 6821 out completely from the PIF board just to eliminate all variables, and I was still seeing the same behavior where the CPU was storing a 0 to the address that eventually makes it to that 6821, and I was noticing that the logic analyzer was showing some looked like bad ROM reads. So I took the ROM out, and this is the programmer I was using, and I like reprogrammed the ROM like 4 times in a row just to make sure that the bits were like really sticking, and then I put it back in, and now it's finally giving me the results I'm expecting. So I still have the PIA 6821 removed. I'm going to try putting that back in and seeing if if it works now. And so I put the 6821 back in, and now it's working. Okay, I have restored this board back to pretty much the way it was before I started. I put back the original PIA 6821. I put back the original CPU. I did add a socket for each of them. I put back the original ROM. I put back the 244 that I took out. So everything is the same as it was before. The only difference is I've reprogrammed the ROM a few times, and I think maybe that's what the problem was this whole time. I kind of got led on a wild goose chase because I pulled the ROM out and read it, and it seemed to read fine. So then I started looking at a bunch of other places. But now I'm going to power on the power supply. Okay, I got it working again. I couldn't do it on camera because I had to manually reset the CPU using a wire, so I had to use 2 hands for that. But as you can see, here's where the CPU powers on, and it sends 2 commands right here on the remote control line. So there you have it. It's working. Problem solved. Okay, so what are my takeaways from this? What actually went wrong? And I believe it was this ROM was kind of starting to lose its program. When I pulled out the ROM and reprogrammed it and read it back in the ROM reader, it read fine, but when I put it back on the board, the CPU was getting some false reads, or there was something, the ROM wasn't quite programmed properly, and so I didn't realize that that could happen due to inexperience, but now I know that just because a ROM reads correctly doesn't mean that it actually is correct. So the way I overcame that was to rewrite the same image like 4 times on my ROM programmer, just for good measure. Because when you erase a ROM, it sets all the bits to 1. So when you rewrite it, you can rewrite it over and over again because it's going to set the same bits to 0 when it writes. So anyway, it's kind of unfortunate that I pulled a bunch of chips, but at least now I have sockets, so that's kind of nice. So now I can declare this board working and keep moving forward with getting StarWriter working on Dexter. Hope you enjoyed the video.